Hello YouTube, what's good? I'm going to be creating a shell scripting tutorial soon. But before I do so, I want to give a little bit of an overview of the different kind of programming languages we have to show where shell scripting fits into the mix and where it's appropriate to use shell scripting. So what you see here is a traditional computer science classification of programming languages. Traditionally we categorize programming languages according to the programming paradigm which they use. And for example, the imperative paradigm is when we're specifying instructions which are executed one by one and modify the state of the program. On the other hand, we have the logical and the functional paradigms, in which we're not telling the computer what to do step by step, but instead we're specifying a problem, which is either a logical or a mathematical problem, and we're telling the computer to figure out the solution to the problem by itself. Last, we have the object-oriented paradigm, which is probably the most used paradigm these days, although functional is also used a lot. Originally popularized by Smalltalk, and in object-oriented programming we have objects which hold state and methods which modify that state. Now this classification isn't clear-cut, because if we look for example at Java, I've put it under object-oriented because it's one of the typical examples of object-oriented, but it actually has imperative code as well. And I'd even go further to say that since Java 8 it has functional programming in it as well, although it's a very limited subset of functional programming. If you want an example of a programming language which is both completely functional and completely object-oriented, Scala would be a good example. So the different programming languages can generally fit more than one of these paradigms. But I want to make a little bit of a different classification. The way I want to categorize programming languages is I want to categorize them according to their relative distance from the hardware. So at the lowest level we have assembly code, where we're directly programming the CPU instructions. So assembly looks something like: store this number in register A, store this number in register B, add the numbers in register A and B, and store the result in register C. It's a lot of work to write assembly code, but it does allow writing extremely optimized code for a specific platform, and it is not portable in any way. So C code is a little bit more portable because you're not directly writing the CPU instructions, but the code is compiled into executable code instead. C does give access to the hardware, so this can lead to less portable code. But C is generally known as the universal assembler because pretty much every platform has a C compiler available to it. So you can compile the code on any platform, but you still need to modify it to support the platform. C is a great language for writing operating systems. Most of the shells in this list are also written in C. And C is also great for writing drivers of hardware. The next level is the shell. In the shell, you basically give commands to the operating system. And the shell allows you to combine different, for example, GNU tools in novel ways. So it's one level higher, it's more at the operating system than at the hardware level. But shell scripting is still a little bit finicky. So if we write, say, enterprise applications, we typically do that in a programming language like Java, Python, C#, and there's many other programming languages. I think most of the programming languages probably fall into the higher level programming category. I'm not just focusing on object-oriented or functional languages here. You could put logical languages in this category as well. It's kind of out of scope for the rest of this tutorial, but it's just to give a comparison. So When I started learning shell scripting, I actually found it rather frustrating, and it's partially because I didn't learn the important stuff first. So I hope that my shell scripting tutorial will make it a little bit easier for others to learn shell scripting. But even now that I have a pretty good understanding of how shell scripting works, I still feel that it falls short for certain problems. And the things it falls short in can be solved easily in these higher level programming languages, but these higher level programming languages generally don't have a good integration with the shell, with the operating system, I guess you could say. So in Java, it is technically possible to run commands on the native command line, but it's not very convenient. And the same is true for Python and probably for C#, although I don't really know how it works exactly in C#. So I've been looking for a language to kind of fit that gap for a long time. And I'd heard of Perl before, but the way I heard about Perl is always in the same manner. It was also, well, somebody wrote a Perl script to solve a particular problem, that person's left, and now we need to make some updates to the script, but nobody understands how the script works. I'm not sure if this is because people don't want to learn Perl, if the Perl intrinsically has some problems that leads to this kind of situation, or if the people who write Perl code are generally programmers that don't read code that can be understood easily. But I never really gave Perl a chance, and that's something at this point, I guess you could say that I kind of regret that, because I recently did learn Perl, and it is a very useful language, and it's a language that I've needed to know for a long time. I just didn't know that I did. Anyway, maybe I'm not giving a very good case for shell scripting right now, but shell scripting has its place, especially if you can solve a problem with a few statements. Then it might be better to solve it in a shell script than it would be to solve it in Perl. But let's look at some more detail first on the different types of shells that we have. So the original shell would be the Thomson shell. This is generally regarded as the first Unix-based shell. The Thomson shell actually didn't have any scripting support, so it only had an interactive mode. So shells generally fulfill two purposes. First of all, there's an interactive mode where you type commands, they're interpreted and executed by the shell. And there's a scriptable mode where you, instead of typing the commands in an interactive mode, you store them in a file, and then you can execute the file whenever you want. And that might be manually, and that might be when the computer starts up, or that might be part of a cron job. So to give an example of the interactive shell, if I open a terminal, I'm currently in the bash shell. That's typically the default shell for Linux-based operating systems. And I could say type a command, the ls command lists the contents of the directory I'm currently in. You could also configure a different shell to run in your terminal, or you can manually call a different shell, and you can see that my prompt changes now because I'm in a different shell. Now, to show that I really am in a different shell, I'm going to show you the dirs command. Now, the dirs command does not exist in the Debian Elmquist shell. I can leave the Debian Elmquist shell, I'm in bash now, and now I can invoke the dirs command, and that's because the dirs command is specific to bash. It's implemented inside of the Bourne Again shell, and it's not actually part of the operating system as a whole. So I'm not going to show what it looks like to run a script file, but that will be part of the tutorial. So returning to the Thomson shell, the Thomson shell only had an interactive mode. Now you won't run into the Thomson shell in the wild anymore because it's generally because of licensing issues and because it's generally been replaced. Now the C shell and the Bourne shell were both developed in parallel by different people at the same time, and the C shell, what I think the C shell is known for is being a better interactive shell than say the Bourne shell, and also it at some point introduced job control, which has been mostly taken over, mostly copied by other shells. The Bourne shell is a very important shell because it's a standardized shell, We actually have the POSIX specification, which is the Portable Operating System Interface acronym. And this is a specification which is implemented to more or less degree by most shells. So the Bourne shell also had some licensing issues, and because of that, Ash and Bash have been developed. So Ash is a completely compliant, a completely POSIX compliant shell that was developed to get around the licensing issues of the Bourne shell, and you could say that it's a literal re-encoding of the Bourne shell. It was later ported to Debian, known as the Debian Elmquist shell, and Bash is a bit of a different beast. So Bash was developed as part of the GNU toolset, and Bash, although it's backwards compatible with the POSIX specification, you can't say that it's completely compliant with the POSIX specification, and it's added a lot of features to the shell. So that results in a binary, in a code base, which I believe is about 5 times as large as the Elmquist shell, and Bash is generally regarded to be about 4 times slower than the Elmquist shell. Now, there's of course an interesting question: is it important that the shell is 4 times slower? And if you're writing a one-off script, you're probably not going to notice the speed difference between the Elmquist shell and the Bourne Again shell. However, if you're writing an operating system, then you will be running a lot of shell scripts on startup. Well, not necessarily, but generally in Linux we do. So the execution time of scripts is actually kind of important, and one example of that is that Ubuntu, and I believe Debian later as well, switched from the Bourne Again shell to the Debian Elmquist shell at some point to greatly reduce startup times of the operating system. The last shell I want to talk about for a little bit is Fish, which stands for the Friendly Interactive Shell. And it kind of doesn't belong in this list because it's not, I don't think we can say that this is a major milestone in shells, but I do want to mention it because I want to give an alternative perspective on what a shell should be like. So Fish was designed not with the POSIX specification in mind. I don't think it's backwards compatible, and generally it's designed to have a less steep learning curve, to be easier to learn, to be easier to use, to give better feedback, all those things. However, you probably won't find Fish on servers, and you might not be able to use Fish professionally. So if you just want to learn how to do stuff on your own computer and you don't have any greater plans with it, I guess I could say, then Fish might actually be a better choice of a shell scripting language to learn than any of the others. In my case, I will be focusing on Dash. Most people use Bash these days, and most of the examples online you will find will be in Bash. I think it's good to know, to have a firm understanding of the basics first before you look at what additional features Bash offers. And I think there's plenty of tutorials on Bash, so we don't need another Bash tutorial. So I hope this gives a little bit of an overview of the different shells that we have. Let me talk a little bit about the pros and cons of shell scripting. So the first pro of shell scripting is that it's very succinct. You really don't need to type a lot of characters to get a job done in the shell. So that's nice. It also has tight integration with the command line, which allows you to reuse anything that's available from the command line. And it's widely available and standardized. Also, shell scripting is very resource efficient. Most of these shells were developed in a time where computers had considerably less resources, and the extra resources just makes it faster. If you solve a problem in Java, then the startup time of the Java virtual machine might be larger than actually running the script you would write in a shell. And then you haven't even started running the code. Now, of course, shell scripting has its cons as well. First of all, there's the very cryptic syntax, which leads to a very steep learning curve and can lead to a lot of frustration. And in my opinion, the syntax of shell scripting is actually quite outdated. If we were to develop a new shell interpreter from scratch today, it would look very different than the shells that we have available right now. The computer science department has learned a lot about what programming languages should look like and how we should design programming languages to make sure that people don't make any mistakes, make less mistakes while writing code. And I don't feel like a lot of that knowledge has transferred into shell scripting. Another problem with shell scripting is error handling. By default, most shells just keep running when they encounter a problem. And there's all sorts of implicit things that happen that might cause problems. Now, to some degree you can get around this, but I'll be talking about that in more detail in the scripting tutorial itself. Also, the expressive power, and this is of course, since it's very simple, very resource efficient, it also doesn't have a lot of expressive power. So there's a lot of problems that are easier to solve in other programming languages than in the shell. And shell scripts are great for basic problems. Sometimes you can solve complex problems in the shell if you have tools you can call that can do complex things for you. But I wouldn't do complex calculations in shell scripts themselves because the syntax just isn't powerful enough for that. And lastly, shell scripting isn't necessarily portable. It's closely tied to what's available on your system. And that might be a problem, it might not. It depends on what the shell script is used for. Shell scripts are great for things that run locally on a computer but don't have to run anywhere else. So, I think that gives a solid foundation for what we can be using shell scripting for, and I hope that gives you an idea where to place my scripting tutorial. I hope this was useful to you.